Welcome to today's lecture. In today's lecture, we will discuss about concerns about nanotechnology. So the past questions while dealing with today's lecture is nanotechnology safe? We have the concern, but in those concerns, the first questions that everybody has in mind that is nanotechnology safe? So you know that as nanotechnology become uh, more commonplace, how careful do we need to be? It's an oral question. When we say that as nanotechnology safe, we are seeing that nanotechnology are the things, the devices that we have in more common places. So, how careful do we need to be while dealing with those devices? We need to deal with those materials. So, in 1986, a researcher called Eric Drexler made a prediction about nanoparticle in the future. So what he suggested that because nanoparticles can build themselves into molecules by self-assembly, self-replicating, nanorobot will consume the atoms of the world as they replicate, so eventually turning everything into a Greco. So, what is Grego? Do you think this is a realistic possibility? It's the concern shown by Eric Drexler in 1986. So he was is mostly concerned about assembly, self-replicating, and nanorobot. And he shows him concern and said that now, we are asking this the same question from you that do you think this is a realistic possibility? So, what problem might be associated with the nanotechnology? That's the today's questions. The question of this lecture is what problem might be associated with the nanotechnology? So, we can have in our mind why is there so much concern about nanotechnology? Though we are using nanotechnology in almost every field of modern technology, we are getting benefit from utilizing different devices and different field of life. But along with that, as mentioned in previous slide, people have concern. So why is there so much concern about nanotechnology? So let's have, because we know that nanotechnology or the nanomaterials or nanoscience have enormous potentials for almost every field in the modern technology. Huge gap, but while we're dealing with the nanomaterials, so there is a huge gap in knowledge concerning the possible risk because nanotechnology, the knowledge of nanoscience and nanotechnology is not so common just like other subjects we are studying. Like we're studying chemistry, we're studying physics, we're studying engineering. So the knowledge is common because the people they are studying at high school, people studying those subjects at the college level or the university levels. So they have more knowledge about everything that have been mentioned in those particular subject. But when we are dealing with the nanomaterials or nanotechnology, so we see a huge gap in knowledge. That's especially concerning the possible risk. So we need to address some of these problems, some of these risks, and particularly we should give attention to those gaps. So there is also difficulty in detecting and removing the nanomaterials because we cannot see some of the nanomaterials. They are not in huge number and huge quantity, so it's difficult to observe them without specialized equipment. So obviously there's difficulty in detecting and removing these. So it's also a point of concern that we should address. And along with that, we have absence of regulations. Till now we don't have any rules or laws. Along with that, we should deal with the nanomaterials. So far we're saying that. Especially if you're living in a third world country or living in a country which is not developed Arab, so those countries or those labs that do not have enough regulations to deal with the nanotechnology. So this might be a point of concern while dealing with the nanotechnology. You know that along with that, we have potential risk associated with the nanotechnology. So, what are those risks associated? So, we have adverse health effect and humans from deliberate or accidental exposure. I mean, you're a person, you are a new researcher, you're working and a nanotechnology lab, you do not know about the proper precaution you should take to deal with those material. So, I mean, you can be hurt by those adverse health effects. I mean, you can observe where your hair or your body, or you can inhale some of the nanomaterials. So those nanomaterials that can be disastrous for your health. So I mean that what should be especially concerned while working in the lab. uh, Adverse effect on the environmental from deliberate or accidental exposure. I mean, again, you are a researcher. You don't know. Sometimes you perform an experiment, and you say that maybe sometimes you feel like the experiment is not on a well go. So what do? You try to you trying to through the product your synthesized product, you want to throw it in a dustbin, you want to throw it outside spot outside environment. So that's the, I mean you can call it as a deliberate or accidental exposure. So while being included in an environment and can produce some serious health related effect, I mean which one should avoid it. Potentially explosive properties of the nanostructures. So yeah, I mean it's also one of the very common problem that might associate with some of the nanomaterial, particularly with those which are toxic material. So, risk assessment problems, how we deal with the risk assessment problems, it's very difficult to detect without sophisticated equipment. I mean, you know that we mentioned in last lectures, due to the smaller size of these materials, we need some specialized apparatus. But you know that those specialized apparatus, they're very expensive. So that's why everybody working at high school level, at college level, or even at university levels, they don't have enough funding to buy those apparatus. So that's why we're saying that it's very difficult to detect them without sophisticated equipment, and the to access those equipment is also very. I mean, it's not like I mean it's a common task to access those sophisticated equipment. Difficult to predict how particle will behave in the environment. I mean, still we need a lot of study. We need a lot of research to do that how the nanoparticle if they goes into the environment, so how it will disperse or how it will come. So we need further research in this field. Though the people are working, but the level at which the nanoparticle they're spreading. They can do the harm. So the scientists they still have not reached that particular point to study that exactly what it should do at the environment. Small size may result in particle passing into the body more easily. I mean, we already mentioned about that. You're working, or maybe you're walking through an environment in which a nanoparticle might have been exposed. So it can you can easily get it into your body through inhalations or injections or absorptions. I mean, sometimes even without any observations, you may come across some of the nanomaterials which might be toxic for your body, and you won't be aware that you have got those material because of the smaller size. You can easily get the inhalation or ingestion or absorption. Maybe more reactive due to surface area to volume ratio. You know that at the starting lecture we have mentioned that one of the properties due to one of the characteristic due to which the nanomaterial have special property is surface to large surface to volume ratio. You know that due to the smaller size, majority of the atoms and the nanomaterial they're lying at the surface due to which actually activity, catalytic property, addition, absorption, now whatever it do with the external environment, it increases. So that might be, I mean, it's also disastrous while dealing with the human body or human tissue if the material is still your toxic one. So potential to observe toxic chemicals. I mean, just like we already mentioned, that your materials your nanochemicals if it's toxic. So I mean it's possible that you might observe those material where your hands or your body spot or maybe some other things which you won't even observe. You won't even be able to see or look around. So persisting longevity of particles and the environment and body are unknown. I mean, still the people need to do the work in this regard. So, toxicological difficulties, you know that all the structures are likely to have a unique toxicological profile until unless we check a particular material. I mean, sometimes you know that we're trying to utilize a particular material for biomedical application. I mean, we want to through it, we want to send it inside the body, and we want to target them to a particular cells, a particular tissues. So before that, we take the biocompatibility or toxic effect. But for all the nanomaterials, we are not interested in that particular test. So that's why we are saying that all the structure are likely to have a unique toxicological profile, which we might be unable to test for. So standardized terminologies agreed recently. I mean, you know that just like in every field, we have some standardized terminologies with which we easily recognize the material or recognize those particular field. So just like that, very recently, such a terminologies has been agreed to develop in the field of nanoscience and nanotechnology. Particle size may be less important than the surface characteristic of the materials. You know that we are saying that the property, I mean the major property of the nanomaterials because of large surface to volume ratio. So in that particular sense, we are saying that particle size may be less important than the surface characteristics of the material because majority of the property of the nanomaterials because of that fact that we are saying that most of the elements they are lying at the surface as compared to the volume. So standard dose response test may not be appropriate. Sometimes we do the test to check the dose, but in this particular case, you're saying that standard dose response test may not be appropriate. So some history. In 1976, Congress passes the Resource Conservation and Recovery Act regulating hazardous waste from its productions to disposal. So, similarly, in 1976, President Gerald Ford signed the Toxic Substance Control Act to reduce environmental and human health risks. In 1977, President Jimmy Carter signs the Clean Air Act amendment to strengthen air quality standard and protect human health. In 1978, a resident discovered that Lock Canal, New York, is contaminated by buried lightning channels container. In 1980, Congress created super fund to clean up hazardous waste site. So, still, in spite of that, I mean, these are some of the efforts that be done by different people, different government societies, or some of the influential scientists or influential communities work to keep the environment clean from the hazardous effect of the nanomaterial. But still, we have question in our mind that is why address nanotechnology. I mean, it's why we are interested in the questions end of life issues that sometimes we are saying that is nanotechnologies too much dangerous to put an end to the life. I mean, it's a very common question that people have, especially in Western society, in their mind that end of life issues associated with the nanomaterial or nanotechnology. So, in this particular regard, we say that very little is known about the effect of nanomaterials and nano waste on human health or the environment. I mean, the first to issue the problem, end of life issues while using or utilizing the nanomaterials. So, to answer this question, we say that very little knowledge or very little information is available about the effect of nanomaterials and nano waste on human health or the environment. We have very few material or few evidence by which we can say that yes, there may be some things true, or maybe still we are at a very early stage to say like this, the nanomaterial may put an end to life. So nanomaterial may behave differently in the environment than the bulk material. It's a well-known fact. We all know the people, especially working in the field of nanotechnology. They are well aware from this fact that the behaviors of the nanomaterial is totally different in the environment than their bulk counterpart. And nanomaterials are already in commerce and the waste stream. People are using in the industries for different applications, and after being utilized, they are already been thrown in the waste stream. So far, no such adverse effect has been felt by uh, the workers or by the people working in this particular field. Um, but along with that, we can also say that since the effect is not being observed, so you're saying that there's no law deals specifically with the nanotechnology. We're saying that since the field is still developing, so there is no such a law that regulates the usage of nanotechnology in different fields. So, public perceptions and concern about nanotechnology, that is how we create and how we utilize and how we dispose the nanomaterial. For example, the first step we take, that is we do the extraction of nanomaterials which lead to the manufacturers. From the extractions we goes to manufacturing of nanomaterials. Then we go to distribution or transport of those material. Once we synthesize or make those nanomaterial, so then the issue is to distribute or transport those material to different lab or to industry for its utilization and different applications. Then after distributions, we have to move this material for manufacturing some nano product. Once being synthesized, so the other step is to carry it to manufacturing of the nano product. So there is a link between the manufacture of nanomaterial to manufacturing of the nano product. That is the question. We say that there might be people who will deal with this material. So industry can deliver. We saying that though this material, it might be synthesized in the industry, and we know that industry can deliver better product like better pen. But what about the guy who's making the pen? We're saying that a person or industry is making the nano pen, so we know that it may be better. The quality may be good, but what about the guy who's making the pen or spraying it? So what will happen to him? Will he be saved, or will he be not? Will he be not affected by the worst impact that one can have from those particular materials? So from the manufacturing the nano product within against go for the distributions or transportations, and that lead to the use of those material, and we come for the disposal. While you're using those nano product after being transported to you at your home, at your offices, so again we are have some questions. We are gonna be killed or care. When you are utilizing, since there is too a little knowledge that we have about nanomaterials and nanotechnology. So again, we are have a question in our mind while we are using this product. We are saying that we are gonna be killer care. We don't know about the effect for sure. So are there labels? You know that on different product there are labels, there are precautions for utilization. So we don't know whether there will be such a label available for the use of nanomaterials or the product who are being made from the nanomaterial. So again, we are saying that it's so small, it can wind up in places you don't expect it. That's the worry. It's due to smaller size, you won't be able to observe it, and it can do the thing you won't be able even to see or to observe. So it getting in unintended places and having unintended consequences. So that is the concern one have in mind while utilizing or using nanomaterials. So then when it comes to the disposal, so again, so one have a question in mind: what happen if they don't break down? When you dispose of materials, so you break down into small species, so that it can be recycled, so that it can be utilized for other purposes. So when it comes to disposal of the nanomaterial or devices being made from nanomaterial, you have a question in your mind. So what happen if they don't break down? How do we get rid of them? I mean, if they don't break down, we want to do the recycle, we want to break it down, but what would happen? I mean, this is the concern and consumer mind. And again, we say that it's like nuclear power. I mean, nuclear power, that we can utilize the nuclear materials for energy purposes, but you know that nuclear waste is one of such a big problems. I mean, the people have. That's why the safe use of nuclear power is a great challenge for the humanity, because the consequences are the problem which is related with the waste product is very, very dangerous for the humans working in that particular field. So what's going on to be the long-term effect? People still working on this particular field. So you're interested in more to study about this. I mean, the link is given. Uh, Here you can see the link has been given. Scores from uh, McAvoy, Janning in 2005 informed public perception of nanotechnology and trust and government. I mean, this is an article from 2005. It's an excellent article. You can learn more about the public perception concern. So it's an excellent article you should deal with. If you have time, so you can consult these articles. You should study for yourselves. Very interesting article, especially when I was studying that for myself. So that's all for this. I hope you enjoy. See you with the next lecture. So till then, bye bye.